Welcome to this presentation. Welcome to this event. Let me tell you about API first development. Now, I believe that many teams out there face themselves with a challenge, and that challenge is the connection between the API specification and the API implementation. So how do we optimize this connection? And how do we make it work in such a way that a reasonable pattern can be devised that works, hopefully, for many teams out there? And if it doesn't work for your team, hopefully, the discussion I am going to have with you right now will help you find a way that works for your team as well. Because as we know, there are no silver bullets in software development. Well, before we get started, my name is Vasco Veloso. I've been around for a couple of decades. I won't bother you with details because you most likely saw them already in the talk description. But I do want to let you know that I am always available via LinkedIn or Twitter to answer any questions that you may have regarding this subject. So feel free, and I will do my best to give you an answer. Or if you just have any suggestion, just go ahead and shout. Now, let's get started with all these API first things, right? API first design, API first development. What does all of this mean? Now, API first design is a way of working where whenever you are designing a software system or a software component or module or service, however you want to call it, that needs to communicate with other systems or other modules. And most systems nowadays, they are distributed, so they do need to communicate between them. Then the first thing that you do after gathering requirements, technical or business requirements, so functional or non-functional, and doing your first analysis in the terms of, how do we divide the system into modules, if you are lucky enough to be doing greenfield. Then, before starting to write any kind of production code, but already getting technical, the idea is that the first thing that is done is to define the API or APIs, plural, that are going to be used for the different services to communicate. And what is the advantage, you may ask? Well, look at it this way. If you start thinking about the data that needs to be exchanged between services, so some sort of functionality can be implemented, then it is very likely that you will find that either your initial assumptions were lacking, or they were too ambitious, or if you are lucky, that they were spot on. Looking at the kinds of requests going back and forth also helps to confirm or discover dependencies in your system, not only between modules, but also data dependencies. And since we are talking about data, it can also happen that looking at the entire payloads, you may get the opportunity to challenge data requirements. So, for example, you may wonder, why is this data required in this specific transaction? Should it not be absent? Or conversely, you may find that in a specific transaction, you need some other piece of information that maybe comes from another module that was not part of the initial design. And now you have just discovered you have a new dependency. On top of that, it also helps you to reason in terms of privacy. We all know that privacy and data protection are very important subjects nowadays. So if you have a version of your API present, then you already know what kind of data is being exchanged, down to the detail. And you can look at what kind of whatever regulations or policies that you need to comply with and see if compliance is possible. And if not, then what needs to be added or removed for compliancy to be possible. And finally, since you are defining the entire API with all endpoints, because although these principles apply to any kind of API, in this case, we are talking specifically about web APIs or REST APIs, then you already have a starting point to start discussing any possible security implications. You can already have a good view over a possible attack surface. So API first design is not only about deciding which data goes where and which requests goes where and who fulfills what. It also gives you the opportunity to think about how you're using data, and also to look at your system as a whole to possibly improve its security, and gives you data later on when you start talking about performance, for example. Now, this is all fine, but there are a few problems that may need to be addressed and are all too common. And the first one is that when teams and people are refining and discussing APIs and discussing in this case, not implementations, but design and making decisions, they often use all kinds of media to support those discussions. There are emails. Some teams like to use Word documents. Others collaborate on Confluence or, I don't know, Google Docs or whatever. And that has no problem in itself. The problem is that using those media as the final support for your API design creates a document that is not technical in nature. There is no connection between that document and the implementation itself. And compounded by this factor, we also have the other problem, is that many specifications, they don't have as much value as they should. For example, they may not have any information about the expected data types for each attribute. They may not have examples. They may actually drift away from the implementation because we are talking about a Word document, for example, stored somewhere, but the code is constantly changing. So it is very easy for the implementation to drift away from the designed API. And then whatever design there was in the first place, it becomes completely irrelevant. So how do we connect these two aspects better? How do we connect the API design the API specification with the code? Well, we can start by using a standard document to describe the API. I'm talking here specifically about Swagger files, so OpenAPI specification version 2, or OpenAPI files version 3 and above, depending on your choice of tooling. But the idea is that these formats, they provide you a plain text file formatted according to one standard. You can mostly choose between JSON and YAML, whatever suits you better. I'm not getting into that war right now. But at the end of the day, you have a technical document that describes your endpoints, the payloads they support, which attributes are there, data types for each attribute, data restrictions to a certain degree, examples, human readable descriptions, all those things that make an API specification good documentation can be expressed in a Swagger file or OpenAPI file. These files, they are plain text. So what can we do with them? Well, we can store them in Git. So we have the possibility to do some code review. Teams can work directly on those files. So they are good for refinement. They are quite technical, yes, but there are tools that allow us to produce HTML formats, for example, and that makes it easier to discuss an API with external stakeholders. Some of them could be more business oriented, and of course, not quite comfortable with reading JSON or YAML. But an API specification in an HTML format, for example, is much more readable. And even though there may be some details in there that are too technical in nature, it becomes easier to explain data formats or just to see what data is exchanged when, for example. And of course, they make great status reports. Another advantage of a technical document in this case is that it can be converted directly into code. Now, I am using Java as an example, and I will be using Java as an example throughout this presentation, but there are other target platforms that can be used. And the idea is that we have a technical document that we can convert into code. And there we have our link right there, that we create the code from the API. But then it goes, of course, into your normal development cycle. But I'm getting a bit ahead of myself. Before we dive into that connection, let me just tell you why I believe that API first design and development as well is a good idea. So according to the Accelerate State of DevOps report from the DORA team, they have identified a number of capabilities that actually help organizations with their DevOps journeys and help them in achieving a better deployment rate, less defects, just improving the overall DevOps journey in the organization. And in my opinion, this approach that I am describing here helps at least two of those capabilities enormously. So one of them is code maintainability. As I mentioned before, the goal is to generate code from the specification. So when that happens, it means that all the code in all the services, at least the interface code, follows the same pattern. That improves maintainability, because if someone needs to look into a different service, then they already kind of know what to expect. On the other hand, if a specification file is good enough to generate code, well, then it is also good enough to support automated testing, because we have tools that allow us to use the specification to exercise its implementation and verify whether that implementation actually fulfills and matches what we are describing in the specification. So we have another opportunity to automate testing and therefore improve quality. API first development, of course, there are some prerequisites, right? So the specification needs to be as complete as possible. And that means that the OpenAPI specification file, the OpenAPI format, needs to be exploited to the maximum, so that all possible data formats, all possible data restrictions are described there. Then it becomes, of course, the source of truth. When we are writing specifications, we must not forget our fellow humans who are going to look at that document and provide human readable descriptions and examples. The examples are useful for humans, but also to automated tools. So there is value in providing examples. And then, of course, as I have been saying, because this is really the cornerstone from this technique, is that code needs to be generated from the specification. Not only the server interface, but also the client code. And then, again, we are absolutely sure that whatever we have running matches the specification. So expectations are fulfilled from a technical point of view. Summing up, and I'm quite sure this is a rehash of what I've been saying, the advantages of following an API first design and API first development is that the specification is the single source of truth. It becomes much harder for code and specification to drift away from each other, because the specification is generating the code and is also helping with testing. And of course, if we generate code, if we generate tests, then we can implement and test API specifications automatically. So, and without wanting to provide a recipe for a fixed pattern, let me just show you some boxes and arrows, because, well, no development pattern presentation is complete without some boxes and arrows. So it becomes clearer what the proposal is. Let's get started with designing the API. So we start thinking about the API. We write the OpenAPI specification, then we design some more, we write some more. And by the time we believe that our specification is complete enough, then we can generate code from it. For example, and I did say that I was focusing on Java-based applications as an example. We can use Maven OpenAPI plugin to generate the code. And by the time we generate the code, then we have the API facade ready, most probably with some kind of stubs. We can then implement and test the business rules that are going to actually fulfill the functional requirements. We can then use the same specification to validate that implementation. There are tools that allow you to do that. For example, Restler or Schema Thesis, that actually fire requests at an implementation of an API based on their specification to see whether the API responses match the specification. So we can test right there how good is the implementation. Well, at any point during this process, we can, of course, go back to the design stage or to modify the specification and start over. When we are happy, we deploy, we have the version 1.0 running, and of course, it's time to start over. Or let me not be so dramatic, to go to the next iteration of our API and our service. And we keep going on in circles as any good agile process. Now, to illustrate how simple this can be, let's imagine that we want a Java service using the Spring framework. Imagine that we write an open API file defining two operations. And of course, it had to be hello world. One will just retrieve a greeting. The other one will save a greeting. So we have a get and a put an operation. They have a number of definitions. I'm not going to get into detail about the open API format here, but you can already see that we can define schemas and all the parameters in the specification. We can also define the data that is going to be exchanged with some data restrictions. We have, for example, a length limitation, a regular expression pattern. All of these are examples of things that we can already express in the specification that document whatever limitations our service impose. And just by configuring the OpenAPI plugin in our Maven build, we can automatically generate a Java interface definition with all the required annotations for the Spring framework to pick it up as a valid API definition. So by the time this gets compiled and runs, we already have a Spring service serving this endpoint. Although with a, for example, as in this example, a not implemented response. And it includes the data model. And the data model in this Spring example will come with all the Spring Bean validation annotations that are required to perform actual request validation before even our implementation gets called. So we have request validation for free. Most data restrictions can be expressed and will be validated in this mechanism. So the actual implementation in our code only needs, in most cases, to concern itself with functional validations. All technical ones have been already taken care of, and clients will get an HTTP 400 bad request whenever they send something that is actually wrong. So the main idea is that we can start with the specification and end with runnable code. And they are linked to one another. What do? We build, we generate, and we extend. We design the API and build the OpenAPI file first. And we use the OpenAPI format to the maximum extent possible to put all model definitions and data formats and data restrictions and descriptions and examples, everything that we can, we should write in that specification. Because then we generate code and we produce our interface definitions, we produce our model files, our DTOs, and then we extend the generated code to add the business functionality, to add whatever functions that we need to. And this ensures that the specification is intrinsically connected to the implementation. So it is very difficult, if not even impossible, for the implementation to diverge from the specification, because the next time we need to make a change, you need to change the specification first, not the code. This way, there is a direct connection between both. And in many cases, not necessarily all situations, but in many situations, this way of working provides a nicer experience than just having everything decoupled. I hope that this brief explanation has helped you with some ideas on how to improve your connection between the specification and the code. Let me know your questions. Let me know your concerns on the platform, off platform, wherever you want. And thank you for coming. Yes, hello. Good day, good night, good evening, depending on where you are on the world. And I see a question from Luigi. Luigi is asking, when the API spec changes, how do you keep the code in sync? Well, if you think about it, you repeat the code generation. So in the example that I was showing, I did not have, of course, the time to show the full example, but this is a complete Maven Java Spring project. So every time you build the project, you have the option to regenerate the interface from the specification. So you edit the specification and you run your Maven build, and then the code gets updated. Of course, there are some other details. You may or may not want to keep generating code with every single build because it may take extra 30 seconds or whatever. So you may want to have a specific profile only for generating the code, but these are optimizations. The idea is that you use Maven or Gradle or whatever build tool you are using, and you incorporate the necessary plugin to generate the code with every build. So if you change the specification, then you change the code in sync. And this is, of course, fully automated. Another question that I have been asked is what's the difference between an API first design and contract-based design? And in my opinion, they are complementary, because the way I see it, you cannot have a real contract without knowing the terms of the contract first, so without negotiating the contract. And the contract negotiating part is when you design the API. So once you have your first draft or prototype of the API ready, then you can define a contract. And in this case, it can be, for example, consumer-driven contract, or and just implement all the contract validation between the different modules. So they don't. An API first design and development does not replace contract-based design or contract-based development or contract-based testing, however you want to call it. Rather, it complements it. And I see we are at the end of our time slot. So once again, I would like to thank you all for attending. And I hope that you have found this presentation useful. And I hope that it has given you some new ideas on how you move forward. Thank you and goodbye.